topic we have in the fourth module comes the settlement of soil. Okay, heavy buildings or structures make the ground compress a little over time due to their weight. Okay, this compression of soil is known as settlement of soil. Okay, so total settlement of soil is primarily three components: immediate settlement, consolidation settlement, or primary consolidation, creep settlement, or secondary consolidation. So it is given by ST is equal to total settlement is given by SI plus SC plus SS. Okay, consolidation settlement is the most dominant factor of total settlement. It refers to the settlement of soil that occurs because applied load causes the rearrangement of soil particles and dissipation of excess pore water pressure in saturated. Okay, so in the settlement, we have main here is the final settlement. Okay, problems are asked based on this. Okay, final settlement using coefficient of volume change. Okay, let us consider a small element of thickness delta z. Okay, we have delta z. Okay, at a depth z in the clay deposit of thickness h naught. Okay, let the effective pressure increment causing settlement be delta sigma dash. Okay, so delta h is equal to mv h naught multiplied by delta sigma dash, representing final settlement as delta sf, and h naught is equal to delta z. So final settlement is equal to mv into delta z multiplied by delta sigma dash. Integrating to find total settlement of complete layer, we get SF is equal to total of final settlement is given by MV multiplied by delta sigma dash into H naught, where MV is the coefficient of volume change. MV is given by AV divided by 1 plus E naught. So delta sigma dash is equal to increase in stress, and H naught is initial increment of soil layer. So E naught is the void ratio. Okay, final settlement using void ratio. So we take delta H is equal to H naught multiplied by change in void ratio divided by 1 plus original whatever void ratio was there. Okay, so it gives you can rewrite as SF is equal to H naught into delta E by 1 plus E naught. So in delta E naught is initial void ratio, delta E is change in void ratio. Okay, this is one of the important equations we have to remember for the problems. So it is using void ratio. Okay, final settlement using void ratio, and we have final settlement using volume change, void ratio, and then next is using compression index. So what is compression index? I have taken in one of the video, that is Cc is given by minus delta E divided by log to the base 10 sigma dash naught plus delta sigma dash. Sigma delta naught dash is the initial stress on soil. Okay, then delta sigma dash is the increase in stress. Okay, divided by initial stress on soil. Okay, it can be, we can take this to this side. So minus delta E is equal to Cc log to the base 10. Okay, sigma naught dash plus delta sigma dash divided by sigma naught dash, where delta is the change in void ratio when effective pressure is increased from sigma naught dash to sigma naught dash plus delta sigma dash. Okay, so SF can be given as Cc divided by 1 plus E naught multiplied by H naught into log sigma naught dash plus delta sigma dash divided by sigma naught dash. Okay, so next is using recompression index. Okay, recompression index in pre-consolidation state. The final settlement are small increase of pre-consolidation soil. Okay, as the recompression index CR is considerably smaller than compression index. It is given by SF equal to CR divided by 1 plus E naught H naught log sigma naught dash plus delta sigma dash divided by sigma naught. Okay, the above equation is applicable when this condition is smaller than the pre-consolidation pressure. Okay, if this pre-consolidation pressure sigma C dash is greater than sigma naught but less than this condition, the settlement is computed into two parts. Okay, that is settlement for pressure sigma naught dash to sigma c dash, settlement for pressure sigma c dash to this condition. So, thus final it gives SF is equal to CR 1 plus E naught H naught log multiplied by sigma C dash divided by sigma naught dash plus CC by CC divided by 1 plus E naught H naught log sigma naught dash plus delta E dash divided by sigma C dash. Okay, in this case, first part is relatively small and is sometimes neglected. Okay, while doing the problem, you will know better. Okay, here we have a problem. Calculate the final settlement of clay layer shown in figure due to an increase of pressure of 30 kilonewton per meter square at mid height of the layer. Okay, clay layer mid height and the pressure increase. Okay, അത് കാരണം ഉണ്ടായ final settlement എന്താണ് നമ്മൾ കണ്ടുപിടിക്കും. Take gamma W. Okay, gamma W is given 10 kilonewton per meter. To also calculate the settlement on water table rise to ground surface. So we have sand and clay layer. Okay, ground surface is here. Distance is given 4 meter, 2.5 meter. So we have to know the what's the final settlement mid of the clay layer. Okay, so CC is given, compression index is given here. Initial void ratio is also given. So delta sigma dash, that is increase of pressure, is given 30 kilonewton per meter square. So initial pressure at the center of the clay layer can be taken as sigma naught dash is 4 into 20. Okay, plus 2.5. What here is 2.5 divided by 2 into 80. Okay, you got 102.5 kilonewton per meter square. Then for this final settlement equation, we have SF, right? CC divided by 1 plus E naught into H naught log to the base 10 sigma naught dash plus delta sigma dash divided by sigma naught dash, right? So we got we have CC, right? CC is already given 0.22 divided by 1 plus what is initial void ratio, that is given, yeah, 1.3 multiplied by what is the height considered for that, 2.5. Okay, into log to the base 10 we have sigma naught dash plus, it is given, increase in pressure is 30 divided by sigma naught dash. Okay, you got that initial pressure at the center of clay layer. Then it is asked when the water table rise to the ground surface. Water table is rise to the ground surface. Okay, what happens? So it is fully submerged, right? Water table is rise to ground surface. It is fully submerged. Then we have to take the sigma naught dash, that is the initial stress on the soil is 4 into 20 minus what, as it is submerged, we minus it with the gamma W, right? It is submerged, right? So 4 into 20 minus 10 plus 1.25, half of it, right? 1.25 multiplied by 18 minus 10, 50 kilometer meter. Then again you substitute it to the final settlement equation, you get final settlement here in centimeter. Okay, due to rise in water table, what happened? Settlement increases. Okay, next we have a simple problem. A clay stratum 5 meter thick has the initial void ratio of 1.5 meter. Void ratio of 1.5 and effective overburden pressure of 120 kN per meter square. So, when the sample is subjected to an increase of pressure of 120 kN square, the void ratio reduces to 1.44. Determine the coefficient of volume compressibility and final settlement of stratum. So, what are given? H naught. What is H naught is given as 5 meter, right? E naught, initial void ratio is given 1.5 meter. What is given? 120 overburden pressure. Sigma naught dash is given 120 kilonewton per meter square. Then we have delta, increase in pressure. Okay, that is given delta E dash. Yeah, correct. Increase in pressure as 120 kilonewton per meter square. Whereas we have a void ratio is decreased, so delta E, that is 1.5 minus 1.44, that is 0.06. So what is the equation for volume of compressibility? Okay, in the theory portion it's given mv is equal to minus delta E divided by 1 plus E naught whole divided by delta E dash. So all the values are given here, right? 1.5 minus 1.44 divided by 1 plus 1.5 divided by 120. So we get the volume of compressed air. Final settlement. Final settlement equation is mv delta E delta sigma dash multiplied by H naught. We have all the values here. You can directly substitute it. Okay, next question is a 3-meter thick clay layer beneath a building is overtaken by a permeable stratum and is uh, underlaying by an impervious rock. Coefficient of consolidation of clay was found to be 0.025 centimeter square per minute. The final expected settlement for the layer is 8 centimeter. How much time will it take for 50% consolidation? We have how much time it will it take for 90% consolidation, how much time it will take for 80% of total settlement to take place. Determine the time required for a settlement of 2.5 centimeter to occur. Oh, compute the settlement that would occur in 1 year. Okay, we have all the values here. Okay, U is given 30, corresponding TV is given, right, 0.071. You take, okay, corresponding values are the permeable layer as shown, clay layer, rock layer, impermeable layer 3 meters is given. Right, what is CV? CV is given as 0.025 centimeters square per minute. Right, it is given CV. Then we have H 3 meter. Okay, it is a, since it is a single layer, we take H is equal to, it is written there, right? It is a below is the rock. Here we have the rock layer, and the up one is the permeable. So it is a single drainage. So CV is equal to TV d square by T. Okay, what is CV is given 0.025. We have to find TV. TV into 300 square, D is given. D is converted to centimeter, 300 square divided by T. So small t is equal to 3.6 into 10 power 6 TV. Right. For when U is equal to 50%. Okay, for A we are finding. What was the question? How much time it will take for 50% conversion? For U is equal to 50%. What is the corresponding TV? 0.196. Right, 0.196. So we directly substitute it. You get it in minutes. Then you have to convert it to years. Okay, you have to convert it to years. How do you convert 705 600 divided by 16 to 24 into 365? You got the value in years. And then second B part, it is asked how much time will it take for 90% consolidation. Right. For U is equal to 90%, what is the TV? 0.848. It is directly given. Right. So you substitute directly, again convert it to years. Next question is when U is equal to C 80% total sum. Similarly, you solve for it also. Then you have when the settlement, determine the time required for a settlement 2.5 centimeter to occur. Right. So what you have to set when you have settlement 2.5 centimeter. So 2.5 centimeter. What is the final centimeter? It is given in the question. Final centimeter you take final settlement you take it as expected to be 8 centimeters. So divide this 2.5 divided by 8 into 100. You get 31.25%. So U is equal to 31.25%. What is the TV? You have to interpolate it. Right. You don't have a value for TV here for 31. So you interpolate it for 40 and 50. Sorry, you interpolate it for 30 and 40. Okay. Then you get the value of 0.078. I think I have explained it in some previous module how to interpolate it. Then what you get TV, then you have a direct value T is equal to 3.6 into 10 power 6 into TV. So you substitute TV, then you get settlement for how much time it will take for 2.5 centimeter settlement. Okay, next E. What is E? Is computer settlement that would occur in 1 year. That would occur in 1 year. So for 1 year, T is 1 year. You take 1 into 365 into 24 into 60 minutes. Right. Small, what is small t? T equal to 3.6 into 10 power 6 TV. Right. So you substitute this value. 1 into 365 into 24. It lasts for 1 year. Right. So divide. So TV is equal to divide this value with 3.6 into 10 power 6. You get TV 0.146. Okay, for TV 0.146. Okay, what would be the U? Okay, again you need to interpolate it. Okay, you'll get the U value. Okay, what is U? U is equal to present settlement by final settlement. So it is given by whatever, as you got U as 42.85, you take it as 0.4285 is equal to settlement divided by H. H is the final set. It is expected to have a final settlement of 8 centimeter. That's why you take here H. So settlement you get it as 3.43 centimeter for 1 year. Okay, try to solve it by your own and try to solve similar problems. Okay, then you have a very simple problem which you can do it by yourself. There are two simple problems. Okay, next, at a site the soil consists of sand up to 3.5 meter depth, and from 3.5 meter depth to 7 meter, the soil is normally consolidated clay. The water table is at 1.5 meter from ground level. The density of sand is 19 kilonewton per meter square above water table and 20 kilonewton per meter square below water table. Okay, the natural water content and specific gravity clay are 60%, 2.65 respectively. The liquid limit of clay is 75%. Estimate the probable settlement of clay if the pressure at mid height of clay layer increases by 40 kilopascal. So we have to find the settlement, right? Estimate the settlement, right? Yeah, what is the equation for final settlement? SF equal to Cc divided by 1 plus E naught H naught log multiplied by sigma naught dash plus delta sigma dash divided by sigma naught dash. So what is Cc? First clay it is given, right? Cc is equal to, in the theory portion is 0.009 multiplied by WL minus 10. What is W? You have liquid limit, right? Liquid limit is 75%. You substituted, you get Cc. So you got Cc, but what is yet to be found? You have to know the void ratio, right? E is equal to ES equal to Wg, right? As it is fully saturated, S is equal to 1. Okay, as it is fully saturated, you take S is equal to 1, you get the value 1.59. Okay, then you find the gamma saturated value, G plus E divided by 1 plus G gamma W is 2.65, plus then you got the E value, then you substitute it and you get gamma saturated. Okay, then it is said that initial stress, okay, is on the middle of clay layer. So we go to the middle of layer. Okay, as it is saturated, you take 19 into here, it is 19 into 1.5, right? Plus 20 into 20 minus, yeah, minus 9.81 into 2. Okay, then you add 16 minus, you got the answer here, gamma sat. As it was not there, we found it, gamma sat minus 9.81 into 3.5 divided by 2. You get a value, you get the initial stress on soil, right? Then you have the increase in stress, that is 40 kilopascal. So you substitute it directly SF to the equation and you get the value SF equal to 0.175 meter. Okay, then you have a very simple problem. Okay, then you can solve it with a direct equations. Okay, there is a small problem with a graph. A consolidated test was conducted on a sample of normally consolidated soil. Following results were obtained. Okay. So we had a void ratio, effective stress. Okay, determine the coefficient of compression. The equation for coefficient compression we know, minus delta E divided by Dr. base 10 sigma 2 minus divided by sigma 1. So you take the graph, okay, you plot it, log effective stress your E here. Okay, you plot the graph here and you take two random values. As it is a slope, you can take the two random values, okay, corresponding. So here it is 1.1 corresponding is taken for delta E, okay, 1.1 minus 0.1 and then log to the base 10, you take the corresponding effective stress. Okay, you take somewhere here, it is taken as 900 divided by 350, 340. 340 is somewhere here, and it given corresponding values somewhere here as 900. Okay, you directly substitute it and you will get a value. That's it.